We'll start off with a problem that we already started. When we were examining Descartes' rule of signs, we did this problem. It was possible to factor out a common factor. We already knew one of the roots. So we already have one root. We're supposed to find as many as we can. And some of the things we used were things like the rational roots theorem. Remember the rational roots theorem? You put the factors of the constant on the end over the factors of the leading coefficient, and you had all kinds of little plus and minus thingies. And that gives you all the possible roots that can be written as fractions. So we've already done the rule of signs. We've taken care of that. We know 0 is a root. We know we're going to have one negative root. So the rational roots theorem, if we have that k of x equals, I'm going to do k2 of x because we already have taken out the common factor. Then the factors of the leading coefficient are plus and minus 1, plus and minus 2. Factors of the constant are plus and minus 1. And the possible rational roots are going to be 1 over plus and minus 1 and 1 over plus and minus 2. So that just becomes plus or minus 1 plus or minus a half. So the rational roots theorem is unusual, but it does say out of all the infinite possibilities for any fractional or whole number solution, here are the only 4 that could possibly work. Do they all work? No. But if a rational root is going to exist, it's going to have to be one of these 4. So we've narrowed it down considerably. Now the next thing we do is try these. Try these maybe in the factor theorem, or you could do long division or synthetic division maybe. The factor theorem said that we could actually plug the root in to the polynomial. If the answer comes out to 0, it's a factor, it's a root. So we need to try one of these. Try 1, try -1, try +1/2, try -1/2. I'm going to try x equals 1. So I'm going to find out what is k of 1. So that would be 2 times the cube on 1 minus 3 times the square on 1 plus 1. Well, that equals 2 minus 3 plus 1. That is 0. So x equals 1 is a root. We know another root. We've got 2 roots now. The thing only has 4 because it's 4th degree. So if this is a root, that means x minus 1 is a factor. We can take x minus 1 times some mystery polynomial, and it's going to come out to 2x cubed minus 3x squared plus 1. One way to find out this mystery factor here that goes with the x minus 1 is to do division. We can do long division, we can do polynomial division, and because this is a 2-term leading coefficient 1, it qualifies for synthetic division, which is just wonderful stuff. So synthetic division, we take the opposite of what's in the factor or the number that's the root, and that's what we're going to divide by. And if you recall, we only take the coefficients. But we have to be careful because we have to have the coefficient on each term. So we have 2 of the x cubes, and we have -3 of the x squares, but we have no x term. So we're going to fill in a 0. And if we were doing long division, we would have to fill the 0 in as well. And then the 1. I'm going to draw a line here and drop the first term. Some people draw little separate lines. I just draw one big one across. And then, instead of multiplying and subtracting like long division, we multiply and add. Much less chance of error. So we have 1 times 2, and then we add -3 and 2. And then we take 1 times the -1, add 0 and -1. And then we take 1 times another -1, and we get a 0. Well, the 0 is remainder, which it had better be because we said that 1 was a factor or root. And what's left over here gives us what goes in here. This is the remainder. This is going to be the constant term. This is going to be the x term. This is going to be the x squared term. We were dividing into an x cubed, so this should be an x squared. So we have 2x squared minus an x minus 1. Well, it's getting there. We already took care of x equals 1. We already took care of x equals 0. And what's left is quadratic. We could use the quadratic formula. We could maybe factor it. We could try that. Let's see if it factors. So we're going to try factoring. Try the good old magic x. A times b would be 2 times -1. I'm sorry, a times c would be 2 times -1. And b is -1. I'm going to try this again. A times c would be 2 times -1 is -2. b is -1. We're looking for two numbers that multiply out to -2, add up to -1. Well, maybe a -2 and a +1. They multiply out to -2. They add up to -1. So this thing here is going to factor. And we'd really like it to be x times x. So a shortcut possibility, because this had a 2 out front instead of just a plain old x squared, if it's 2x squared, that means our roots here are twice as big as they need to be. So we can divide them each by 2. So the one factor is going to be x minus 1. And the other factor is going to be x plus 1/2. Because this reduces to -1, this stays 1/2. That means x is going to equal 1, or x is going to equal -1/2. And we already had that x equals 1. And we already had that x is 0. So our solution is x equals 0, that was the first root we got. X equals 1, that was the second root that we got from the factor theorem. And this is a double root because it showed up again when we factored this quadratic part. And x equals -1/2. So we have all 4 of the roots that we needed. and the problem is solved.